the composition. Next, what happened afterwards? What is the problem with the solids? These are solids, no, ceramic, paper, glass. These are solids. Bringing the exact shape of the capacitor was the problem. Say we do discuss parallel plate. Parallel plate is an ideal. I'm saying that it's just an ideal. Nowhere parallel plate. It's just an ideal concept. To design any capacitor, I'll approximate it as parallel and I'll solve circuit problems. This is not used anywhere in application. I'm making things clear, parallel plate. Then, so if you look at the more popular, what we use, cylindrical, that one. So in cylindrical, again, ceramic, that particular insulators, solid insulators, making shape as that of volume of capacitor was a big problem. So later on we introduce oils. So now what all you purchase, no? Oil-filled capacitors, oil-filled condensers. Technical word for capacitors is condenser. Nobody say capacitor. If you look at the technician, he'll just say condenser. What is the advantage with the oil filled? Very easy to fill up the volume of capacitor. What is the shape of the capacitor? It will occupy that particular shape, and they also offer good, so like a relative permittivity. And even if it gets if you want to refill, no, you can refill it, provided if capacitor permits. So that's why the oil-filled capacitors are more popularly used than other thing. That one almost you can say from past 20 years we are going for oil-filled capacitors. Okay, let's let's go for this dielectric inside the slab. So if you look at the capacitor, so this is a dielectric slab. So what actually inside it is already, I think we have discussed this. It consists of dipole. Now if this I put plus Q charge, minus Q charge, the dipoles will align in one specific direction, and because of that we'll get net induced charge, minus plus, minus plus. They may ask you simple diagram based questions of like this. If a dielectric slab is introduced between the plates, how the dipoles inside that? So the net here will get minus Qi plus Qi, and this is slab. Then I'll keep on increase the charge on the capacitor. So there are three fields are there, no? One E naught, then induced field, then E naught by K. What is E naught by K? Is the resultant field. So you look at one dipole. One dipole is nothing but one atom it is. This is the one dipole. So the electrostatic force E naught by K, it will exert a force on the positive charge, it will exert a force like this. On the negative charge, this is the electrostatic force here. On the negative charge, the force will be in this direction. And what about the molecular force? The molecular force will be acting. So let me show with the other color. So there's the molecular force called Fm. I'll keep on increase charge Q. So we know as Q increases, E naught will increase, and Fe depends on what? F equal to the charge of the dipole. Let me call Q. The charge of atom, charge of nucleus, and charge of revolving particles. So this should be equal to QE. As I increase the charge Q, as Q increases, E naught will increase. E naught by K also will increase. E naught by K also will increase. So Fe will increase. This was the sequence it happens. So at one particular instant, if Fe greater than Fm, I think it's clearly visible, no? The Fm is molecular force here. So at one instant, if Fe is greater than, Fe greater than Fm, What will happen to the particular atom? The revolving electrons, what happen? They'll become free from the atom, and we'll get some sort of like a flood of electrons, large number of electrons, and these electrons are binded. So you look at this negative charge. It's nothing but the net negative charge, net revolving charge of particles. The total electrons, the charge we show minus q, that one. In fact, these dipoles are not fixed here. I think you should go back to the modern atomic structure. What is the state of electrons? Will be revolving. That electrons revolving, and the atom also, and the nucleus also will be revolving. Both the electrons as well as atom, they'll be revolve about common center. We are just showing one approximate diagram. This is a dipole. And due to thermal agitation, what will happen to this dipole again? This will be vibrating about mean position. This is what overall sequence happens inside. Now, as I keep on increase the charge on capacitor, so I give the sequences what will happen. So based on that, now the moment when electrostatic force becomes greater than molecular force, then what happens? These electrons are no longer binded to the nucleus of the atom, and they'll become free. So when Fe greater than this one, so minus Q will become free from plus Q. So what is this minus Q? Charge of revolving electrons. And what about this is charge of nucleus? What should happen to these electrons? No, they are available in the slab, no, and there's electric field is also there. So there'll be, shall I say, net displacement of charges will occur, drifting will occur. So, and because of that, what happen? There'll be flood of electrons, or there'll be flush of electrons. The large amount of current will flow, and heat will be generated. And what happened to slab? Slab will burn out. That's why whenever you see capacitor, no, as due to high voltage comes. So what actually happens, like if you look at the fan, refrigerator, even in television, the mixer, so almost all which will run on the electric power, capacitor is a some sort of like a protecting element. First what happens, who will get damaged? The capacitor will get damaged. If you look at the fan, cost of fan 2000, condenser at the most best quality 40 rupees. So when high exceeding voltage comes, the charge across capacitor will increase. Then the electrostatic field, the electrostatic force will become greater than molecular force, and the dipoles will, so like the revolving, the dipole will, so like you can say, it will break out, and large current will flow, and it will be generated, the slab will burn out, and you'll get some sort of spark. Sometimes what happen if you're nearby it, no, if it is the oil field, no, that oil, what happen if it falls on your skin, you may get burns also. So these are the some complications are there with oil field regarding the safety. If there's some sort of like a solid dielectric slab, no, the paper will come out. The paper will be huge amount of paper will be crushed inside that one. That paper will come out here. So when it comes capacitor, there must be a safety. There must be a safety, that one. So when the voltage across capacitor becomes greater than that, there'll be chances of the slab may come out with a force. That one, if the oil will get spilled up and burns also may possible. This called like a breakdown. So what is the electrical breakdown we see? So in terms of that's why if purchase any capacitor, no, on that it will be written 100 volt, and it will be written 20 farad. What do you mean by that? This is the maximum permitted voltage. If the voltage becomes more than this, the capacitor will burn out. The reason is because of this condition. So directly they may, everyone will give 100 volt, but in your books open they give the field, the maximum electric field inside the slab is, if the field is greater than that, the slab will burn out. So if you go for technical, they'll mention voltage. In textbooks open, the numerical, they just bring the word Emax. If the field across dielectrics in the slab on the capacitor is greater than that Emax, the capacitor will burn out. Now, what to do with the capacitor after getting damaged? You have to replace with a short circuit. Because a large amount of current will flow, it will become a short circuit here. So so definitely, shall I say there is some upper limit for the charge, or there's a maximum permitted voltage? There's a maximum permitted voltage. So when V across capacitor less than Vm, no breakdown. Or V greater than, equal to also should not be operated. V greater than, breakdown occurs. After breakdown occurs, what you should do? You should replace capacitor with a short circuit. For a while, it will become short circuit. Okay, the basic idea of this. Any theoretical questions can be asked. You have to be careful. So therefore, shall I say, since can we also go for charge? Maximum charge should be equal to C into Vm. Any questions? What is maximum permitted charge? We can put any amount of charge in capacitor. Once if the charge exceeds certain value, no, Qm, the field inside the slab will become greater than that Emax and it will burn out here. This is about the theoretical background. At that instant, short circuit.